afternoon, students. I am NV Krishna Rao, Assistant Professor CSE Department. I am handling the compiler design for the 5th semester. So, in the last class, we have discussed the definition of the DFA and few examples. So, we will continue with some other example and we'll start discussing NFA, Non-Deterministic Finite Automata. This is the previous examples we have discussed. Now, we'll discuss the construct of DFA for accepting strings having 10. This 101 may exist at the starting, or middle, or end in any place of the string. Now we have to construct a DFA for this string. Now we will construct DFA for this string. So what is our condition? X 101 y. This is a string to be which we have to construct, right? Here we can take the condition. We start with the initial state Q0 and on 1 it goes to Q1, on 0 it goes to Q2, on 1 going to final state. So we are considering the condition as the transitions. So there are three symbols we are considering the Q0 to Q. To indicate initial state, we are using the arrow. So we are using the double circle as a final state. Now, what the DFA says, each state on each input symbol should have a transition. So Q0 on 1 going to Q1. We have already considered. Now we have to find Q0 on 0 where it goes, Q1 on 1 where it goes, Q2 on 0 where it goes, QF on 0, QF on 1. Wait, we have to find these other transitions. According to our condition 101, what are the prefixes? Epsilon, 1, 10, 101 are the prefixes. Now, Q0 on 0, we have to find the transition. Is 0 is the prefix of our string? No. So, it must follow. It must follow. It must follow the condition 101 to reach final state. So, which state on the condition 101 reach the final state? So, it is Q0. Q0 is a state on 101 reach the final state. So, now consider this assumption. Q0 on 0 goes to Q0. So that it will follow our condition 101 to reach the final state. Now, Q1 on 1, where it goes? We have to find. How we reached Q1? Q0 on 1 going to Q1. Now, 1 is a prefix, our string. Is it prefix for our condition? No. So, we skip this one. 1 is Q1 on 1 we have to find. 1 is a prefix of the string as. So what is the other required symbols? 0, 1 to reach final state. Now which state on 0, 1 goes to final state? That is Q1. So here what it is implying? Q1 on 1 goes to Q1 only, right? Q1 on 1 goes to Q1 only. Now, Q2 on 0 we have to find. How we reach Q2? Q naught on 1, Q1, Q1 on 0, Q2. Now, the string is 100. Is the prefix? No. So skip 1. 00 is a prefix? No. Skip 1. 0 is the prefix? No. Skip this 0. So what is the condition? It required follow 101 to reach the final state. So what is state which follows 101 to reach the final state? It is Q naught. So what is it implying? Q2 on 0, it has to go Q. Q2 on 0, it has to go to Q2. Right? So Q2 on 0 also form. Now, how we reach final state? Q0 0 goes to Q1. Q1 on Q0 on 1 going to Q1. Q1 on 0 goes to Q2. Q2 on 1 going to Q. Already the condition is satisfied. After the condition means y. Y is a sequence of 0 ones is accepted. So simply we say QF only. Because after the condition either 0 or 1 it is accepted. So for 0 we are considering as QF only. Now Q0 on 1 Q1, Q1 on 0 Q2, Q2 on 1 going to QF. Already 101 is there. After the 101, any zeros or ones are accepted. So simply QF on 1 goes to QF. So QF on 01, simply we write goes to QF. Right? Now this is the transition diagram. From the transition diagram, we can write our transition table. 01, Q0 is the initial state. On 0, Q0. On 1, Q1. So Q1 on 0, Q2. On 1, Q1. Q2 on 0, Q0. Q2 on 1, QF. Then QF is a final state. On 0 it's a QF only. On 1 is a QF only. So this is a transition table. Right? Now, 5-tuple notation. M equal to set of states, input alpha bit, transition function, initial state, set of final state. So, what is a Q? Set of states. Q0, Q1, Q2, QF. Then, what is alpha bit? 0, 1. What is a initial state? Q0. What is a set of final states? QF. Right? Then, what are the transitions? Q0 on 0. It is Q0. Q0 on 1. Q0 on 1 is Q1. Q1 on 0. Q2. Q1 on 1. Q1. Q2 on 0. Q0. Q2 on 1. QF. QF on 0. It's a QF only. QF on 1. It is QF only. Okay, so we have written we have completed the 5 tuple notation, transition diagram, and transition table for the example. Now we'll do for another problem. What is that one? X101 means ending with 101, right? Ending with 101. Previous example containing with 101. So here we'll consider Q0 on 1, Q1 on 0, Q2 on 1, Qf. So this is the same as previously. Here the transitions on Q0 on 0, Q1 and Q2 will be the same as previously. Simply we consider Q0 on 0 is Q0, Q1 on 1 is Q1, Q2 on 0 is Q0. We are considering the previous transition table up to this one because the same procedure. Q0 is the initial state, Q1, Q2, Qf. Q0 is Q0, Q1, Q1 on 0 is Q2, Q1 on 1 is Q1, Q2 on 0 is Q0, Q2 on 1 is Qf. Till this, all the transitions are the same. Now, we need to find Qf on 0 where it goes. Q0 on 1, Q1, Q1 on 0, Q2, Q2 on 1, Qf. 1010 is the prefix? No. 0 is the prefix? No. 010 is the prefix? No. 10 is prefix. Now what is required? It's required another one to reach final state. Now tell me which state on 1 goes to final state. Which state on 1 goes to final state? That is Q2. So consider here Q2. Consider this assumption. Qf on 0 goes to Q2. Q2 on 1 once again reaches the final state. So previously we have considered Qf on 0, 1 reaches the final state directly because Y is the sequence of 0 and 1s. But now the string condition is the strings accept the strings containing 101 at the end. So we need to find Qf on 0 will be accepted or not. So that here we are getting Qf on 0 goes into Q2. Say now for the Qf on 1 where it goes. Now how we reach Qf? Q0 on 1, Q1 on 0, Q2 on 1 going to Qf. Now Qf on 1 we have to find. So what is the string? 1011. The string is 1011. Is the prefix? No. 011 is a prefix? No. 11 is the prefix? No. So we'll simply skip. 1 is prefix. So after 1, it requires 01 to reach final state. So what is the state? What is the state on 01 reach the final state? It will be Q1. So Qf on 1 goes to Qf on 1 goes to Q1. So that after 1, it will follow 0, 1 to reach the final state. Okay. So here QF on 0 is Q2. QF on 1 is Q1. This is the completion of our transition table. So we have considered transition diagram, transition table. Already you know how to write the 5 tuple notation. One string for acceptance, one string for not accepted. Right? So these are some examples for DFA. Now, next comes to the non-deterministic finite automata, NFA. Here, this non-deterministic finite automata, there is a first difference, DFA to NFA. Here, DFA says that each state on each input symbol should have one and only one output transition. Here, NFA says that it might be 0 or 1 or more number of output transitions. Right? So here, it says that it might be 0 or 1 or more number of output states. It is not uniquely determined, is more than one state at the same time, and also which choices leads to solutions. Here it is considered a number of viable choices available at some point, not knowing which choice leads to solution. So here, when you are finding some string is accepted or not, we have to consider all the possible choices, so that one of the choices may leads to final state. If it reaches one of the choices leads to final state, then the string is accepted or it is not accepted. So here deterministic says that there is only one path. So here one state to another state, only one output state. For each state there is only one output state. So finally it gives it is accepted or not. But in non-deterministic finite automata, a state may give multiple output state. Each one will be considered for next input symbol, and it may lead to, after accepting the input string, one of the paths will reach acceptance, final states, or not final states. If they have reached the final state, one of the path reaches the final state, the string is accepted. So here if we check, one path reaches here, another one path this one, and another one, this is a path and this is a path. So it may reach some of the states. After accepting the input string, it may reach some of the states. If one of them is a final state, the string is accepted. Otherwise, the string is not accepted. So that is the main difference between the DFA and NFA. Right? So here, on acceptance of some string, it will give some number of states as an output. If one of them is the final state, the string is accepted. Otherwise, not accepted. So, here, ability to take a step without reading any input symbol, that we say has NFA with epsilon. Right? So, a state may have no transition on a symbol also. Right? Here, there is no transition on symbol also, and ability to transition to more than one state on a given symbol. Right? It may be zero symbol, it might be one or more output state without a symbol also. It may have a transitions that we say as NFA with epsilon. Right? Here, this NFA also we determine with a 5 tuple notation. Q is a set of states, alphabet, a set of input alphabet, a transition function, right? A transition function, and Q naught is a initial state, F is a final state. Here, this NFA we considering as an ability to become as NFA with epsilon. Here, if you say NFA, then we'll specify as state on input alphabet use power set of Q. PQ nothing but power set of Q. And NFA with epsilon. NFA with epsilon. We define its transition as state and input alphabet with input alphabet with epsilon transition, means no transition will result power set of Q. Right? NFA, this is the NFA transition, state on input symbol give power set of Q. NFA with epsilon says state on epsilon with alphabet will result power set. Alphabet with epsilon will result power set of Q. Then F is final state. Right? So Q is a set, P of Q's power set of Q. Right? Then if XYZ is a set, then what is the power set of Q? Empty set, only XYZ. Then all possible of combination of two states, XY, XZ, YZ, and all the three XYZ. It's a set of all the subsets of given set. Set of all the subsets of given set called as power set of given set. If S is a set containing XYZ, then power set of S we representing as empty set containing X, containing Y, containing Z, containing XY, containing XZ, containing YZ, containing XYZ. Now, construct NFA for accepting two consecutive zeros. Now, we'll check these two example construction. So, what is the first one? Containing two consecutive zeros, where x comma y belongs to a sequence of 0 ones. Close. Now, here, what is the condition? Containing two zeros. Simply we says Q0 on 0, Q1 on 0, QF, where Q0 is the initial state. Right? Then, what is the X? Now we are constructing the NFA. What the NFA says? it may have 0, 1 or more number of transition, a state or input symbol. So we have written the condition Q0 on 0 going to Q1, Q1 on 0 going to Qf. Now Q0 on 0, 1 goes to Q0, which resemble the X. What is X? A sequence of 0 ones that we are representing as Q0 on 0, 1 going to Q. Now, what is a Y? Y is a sequence of 0 ones. So, here QF on 0, 1 going to QF. QF on 0, 1 going to QF. Here, this QF on 0, 1 going to QF will resemble Y. Right? Is it clear? What is X? What is Y? Here, this is a completion of the NFA. The transition diagram NFA is over. We can easily write NFA transition diagrams, a table. We can construct NFA. But checking of a string is accepted by NFA or not is a lengthy process. Now, we'll see it's a transition table. Transition table contains 0, 1 as the column headers, then initial state Q0 and Q1 is another state, and QF. We represent QF as a final state. Now Q0 on 0, there is two output states. One is Q0, another one is Q1. Q0 on 0, there is a two output states, Q0 and Q1. But Q0 on 1, there is only one output state, that is Q0. Next, Q1 on 0, QF. Right? Q1 on 1, Q1 on 1, 5. There is no output transitions. QF on 0, QF. QF on 1, QF. Is it clear? QF on 0, 1 is a QF. This is the completion of the transition table. If we observe, NFA says that a state on input symbol may give 0 or 1 or more number of output states. So here this is the 0 output states. These both are 1 output states. Here this one Q0 on 0 giving 2 output states. Right? So this is the NFA definition. Now we'll see the 5 tuple notation. Right? M is equal to Q input alpha bit, transition function, initial state, set of final state. Q is Q0, Q1, QF. Then input alpha bit 0, 1. Transition function will Q0 on 0 giving Q0, Q1. Q0 on 1, Q0 only. Q1 on 0 is QF. Q1 on 1 is empty set. QF on 0 is QF. QF on 1 is QF. Then initial state is Q0. Set of final states QF. Right? Here we have represented 5 tuple notation, transition table, transition diagram. Now we check for one string 11001. Is the string is accepted or not? First we start with the Q0. Q naught on 1, Q naught. Q naught on 1, Q naught. Q naught on 0, Q naught and also Q1. Then what is the next symbol? 0. We have to consider the next symbol 0 on both Q naught and also Q. Here Q1 on 0 reaching the final state. Q naught on 0 giving Q naught Q1. Q1 on 0 giving QF. Now there is one more symbol. What is that? 1. Q naught on 1. What is the output? Q naught. Q1 on 1. Q1 on 1. Empty set. QF on 1. QF. So finally we are getting Q naught QF. In that 1 is belongs to a set of state. The string is accepted. So for Q naught on 0, we have to consider both output states, Q naught, Q1. These both the states we have to consider for the next input symbol 0. Right? So we have to find Q naught on 0, which gives Q naught Q1, Q1 on 0, which gives QF. Right? So finally it gives Q naught and Q, a set of final states. Now we represent standard form. So Q string transition function Q naught on 11001. So Q naught on 1. Remaining symbol 1001. Then here Q naught on 1, simply Q naught. Right? So it is Q naught 1001. Now consider Q naught on 1. Here Q naught on 1. Trying string. Remaining symbol 001. So string transition function. This Q naught on 1 giving Q naught. So Q naught followed by 001. Then Q naught on 0. Remaining symbols 0. What is Q naught on 0 giving? Q naught and Q1. Both we have to consider them for the next input symbol. So which leads string transition function transition Q naught on 0 union with Q1 on 0 followed by next symbol 1. Here this one results Q naught Q1 Q1 on 0. What it says? Q1 on 0. QF. So finally what it is giving? Q naught is giving Q naught Q1 QF on 1. We have to check. Q naught on 1 union with Q1 on 1 union with QF on 1, which leads to finally Q naught QF. Which of them belongs to a set of states? So the string is accepted. Right? Now, what is the second example? Constructing NFA for accepting strings ending with zeros. Now we'll check. Now, what is the problem? X 0 0 ending with zeros, where X belongs to a sequence of 0 1 closer. Here we write Q naught is the initial state, our condition Q1, Q0 on 0, Q1, Q1 on 0, Qf. Right? Now, what is X? A sequence of 0 ones. Simply. We have represented our condition. We have represented X, Q0 on 0, 1 going to Q0. This is the completion of our NFA diagram. This is our completion of the NFA transition diagram. We have represented X. We have represented the consecutive zeros, 0, 0, ending with 0, 0. Now, write the transition table. Transitions 0, 1 and initial state Q0. Q0 on 0. It's a Q0 and Q1. Q0 on 1. Simply Q0. Right? Then Q1. Q1 on 0. QF. Q1 on 1. 5. Now, QF on 0. 5. QF on 1. 5. Where QF is the final state. So this is the transition table. Right? This is the transition table. Now, we check for the string 1001 is accepted or not. According to, by seeing the string, we can conclude it will not be accepted. Now we have to prove that. Right? String transition function Q0 1001. So which results transition function Q0 on 1 followed by 001. Then string transition function Q0 on 1 which results to Q0. Take this Q0 on 0. So Q0 on 0. Remaining symbols 0, 1. Now what is the Q0 on 0? Q0 and Q1. Take this Q0 on 0 union with Q1 on 0. Remaining is 1 is the input. Now, what is the Q0 on 0? Q0, comma, Q1. Q1 on 0 is a 5. Which results to Q1 on 0 is a Q1 on 0 is QF. Which results to Q0, Q1, QF. And this 1 is input. Now tell me, Q0 on 1 union with Q1 on 1 union with QF on 1. What is the final we are getting? Q0 on 1 is a Q0 only. Okay, Q0 on 1 is Q0. Q1 on 1 is a 5. QF on 1 is 5. So finally we are getting Q0 only, which is doesn't belong to a set of final state. Which is doesn't belongs to a set of final state. So the string is not accepted. So the string is not accepted. If we consider 1100, we'll check. Q0 on 1 is Q0. Q0 on 1 is a Q0. Q0 on 0 giving Q0 and also Q1. Then on 0, which is giving Q0, Q1. Q1 on 0 is a QF. So finally it's resulting Q0, Q1 and QF. One of them belongs to a set of final states. The string is accepted. Therefore, the string is accepted. Right? So, We'll discuss some more examples in the next class. So by this NFA definition and an example for NFA, I'm closing this section. Thank you. So we'll continue in the next class with some more examples.
Like, share and subscribe. Hit the bell icon for more updates.